Hey, this is Math Minutes Pro with Dr. Harrison. Today, we're going to talk about how to write and graph inequalities on a number line. Now, remember, we use mathematics to represent and to describe things that occur in life or to describe a set of numbers. In this case, when you're dealing with inequalities on a number line, you can use an inequality, which is a math sentence or a graph that represents an inequality, to describe a set of solutions. Okay, so before we get started with writing and graphing and solving the inequalities, let me give you some basic information because we're going to need to remember this when we graph the inequality. Okay, and it'll make more sense once we solve a few problems. So when you're graphing an inequality, if you have an open, if you have a less than symbol or greater than symbol, okay, then we're going to have an open circle, okay? Now, remember this, when you're reading an inequality, you read it from the left side, not the right side. So from the left side, this says less than. From the left side, this symbol says greater than, okay? Now, if you have an inequality that is less than or equal to, or greater than or equal to, you're going to have a closed circle. And what that means is that it includes the number where this closed circle is as a solution. So let's go ahead and get started, solve some problems, and I think this will make more sense. Now, first, if I give you an inequality that says x is less or greater than 3, and I say graph that inequality, the first thing you want to do is draw your number line, okay? Second, identify 0. That's the first thing you want to do, all right? Because you want to identify 0 so that you can know where to place that number on the number line. Okay, so I'm just going to draw a hash mark and say this is 3. Now let me come over here and decide what type of circle to use. This is greater than, x is greater than 3. So I'm going to use an open circle. Okay, so let me use a different color for that. That's an open circle. Now let's read this sentence again. All values, now one way to read it is x is greater than 3, or all values of x greater than 3. If it's greater than 3, the values of x are going to go to the right. It means all values of x greater than 3. Okay, so a solution could be 4 to this inequality, could be 4. If I plug in 4 for x, 4 is greater than 3. That's true. Another solution, so why don't we do that right now? Let's just write the solution set. Okay, so we say all the solution set for x, that's what that means. Solution could be 4. What else is greater than 3? 8, 20, okay? All right. There are a lot, we can say infinitely many solutions, but they have to be greater than 3, okay? So what we did here is we were given an inequality sentence, we graphed that inequality, and then we identified a set of solutions, okay? So I'm just going to say these are a set of solutions, okay, right here. All right, let's do another one. Let's solve another problem. What we're doing is we're building your understanding of inequality. Some students know how to solve the inequality, they know how to graph it, but they don't know what it really means, okay? So I'm taking time to do that. Let's say we have something that says, we have an inequality that says V is less than or equal to -5. And we want to graph this inequality and then describe the set of solutions, okay? So here we are. Let's go ahead and draw our number line. Okay. Second thing, identify what? 0. Okay, now decide where to place -5. Okay. Now, so we can place it over here. If you want to write, all the hash marks to get to -5, that's up to you. All right, so let's read this inequality sentence. It says all values of V less than or equal to -5. So check over here. If it's less than or equal to, it has to be a closed circle. Okay, so let's go ahead and make our closed circle. Okay, and it says less than -5. The values of X that are less than -5 go to the left or the right. Yeah, it goes to the left. These values are less than -5. Okay? All right. So in this case, what would be a set of solutions that make this inequality true? Well, think of a number less than -5. Yeah. Could be -6. Could be -7. Could be -30. And you could keep going. All right. So all values of V that are less than or equal to -5. Very good. And remember, this represents a solution set here, okay? A set of solutions. Or you can say a set of solutions. Sometimes you may have a problem where they ask you to give a solution that makes this inequality true. Well, if we plug in -7, -7 is less than -5. -30 is less than -5. So, very good. Okay, so now let's focus on writing the inequality when you're given a graph. You can see that I covered up the graph, all right? So in this case, we're just going to write the inequality when you're given a graph. And another way to think about it is we're going to go from the graph to the inequality. So let me erase that. We're going to go from the graph to the inequality sentence. So the way that works is you're usually given a graph, and let me get the graph up here for you. If you're given a graph that looks like this, and then you're asked to write the inequality. Now you're going backwards. In previous problems we solved, you were going from the inequality to the graph. Now you're going from the graph to the inequality. Another way of thinking a different way. So let's interpret this graph. It says all values of X that are, that's a closed circle, and it says less than or equal to. Less than or equal to -2. That's it. All values of X that are less than or equal to -2. And that's it. So when you're given a graph, you think about it that way. Let's do a couple more. Just to give you a chance to practice this. So here is the number line or the graph. Okay, that's the number line, or the graph rather, the graph. And now what we need to do is write the inequality sentence. Okay, so if you don't want to use x, that's okay. All values of, not use x, all values of, I don't know, what's your favorite letter? K, okay. All values of k, now look at that. It's moving, it's an open circle, so it's one of these symbols, and it's going to the right, so it's greater than 3. So all values of k greater than 3. The solution is all values of k greater than 3. This is an inequality sentence, and that's the answer. So it requires a little critical thinking and analysis. You're analyzing this graph. You select your variable. You look at your circle, and you say, is it open or closed? It's open, so you're going to use one of these two, and it's referring to the values of k that are greater than 3, and there it is. All values of k greater than 3. Now I can use any letter, doesn't matter. Okay, let's do one more. Number line. Identify 0, -8. And I will make this an open circle and have it go in that direction. Okay, let's think about it. We need to come up with write the inequality sentence. Well, what letter variable do we want to use? What letter for the variable? I don't know. How about Q? Okay, all values of Q, open circle, and looks like they're greater than -8, so we write greater than and -8. All values of Q greater than -8. Here is the picture of the model, and here is the math sentence. And then the word sentence, I'll speak it this time. All values of Q greater than -8. All values of Q greater than -8. Very good. Let's go ahead and prepare to now solve some inequalities. All right? And then we're going to graph them and then describe them in a sentence. Let's start with inequality. If you're given an inequality that says g minus 5 is greater than or equal to 6, okay? That's our inequality. Notice it's not an equation. We don't call it an equation because it doesn't have an equal sign. It has one of the 4 inequality symbols. So it's called an inequality. So we're going to solve some problems where we use addition property of equality and subtraction property of, well, I should say inequality. So addition property of inequality and subtraction property of inequality, because we're not dealing with equality but inequality. All right, so first thing we want to do, remember, we want to isolate the variable g, get g by itself. What's the opposite of subtracting 5? You add 5. Whatever you do to one side of the inequality, you do to the other side. So you add 5 again here. Draw your line. And -5 plus 5 is 0. And remember, we're adding down, okay? So g plus nothing is g, or 0. So g plus 0 is g. Add down, you get 0. Bring the inequality symbol down. That's greater than or equal to. And then 6 plus a positive 5. That is 11. We have solved the inequality. It says all g is greater than or equal to 11. Now what we want to do is graph the inequality. Here is our number line. Next thing we do is identify what? 0. And then where would I place 11? Okay. I would place 11, let's say over here because it's greater than 0. So I'll place 11 right there. Now, look at the inequality that we have in this original sentence. It says greater than or equal to. That means we would have a closed circle. So let's put our circle here and just color it in as if it's closed. That's a closed circle. I'm going to talk about what that means too in just a moment when it's closed. Now, all values of g greater than or equal to 11. So then the values that are greater than 11 go this way. Now, in terms of thinking of a solution set, so we graphed that inequality. Now let's think of the solution set. So all values of x, what would be a solution? Well, what value is greater than 11? Could be 12. Could it be 11? Yes, it could be 11 because it says greater than 11 or equal to 11. Now, so in other words, when you have a closed circle, the number where you have the closed circle is included in your solution set. Because if I plug it in, I get 11 is not greater than 11, but 11 is equal to 11. So yes, 11 is a solution. If I had less than or equal to, it would not include that number as a solution. Okay? All right, so another solution could be 45, and keep going. Infinitely many numbers, but they have to be greater than or equal to 11 as a solution. And remember, this is our solution, or I'll say this time a set of solutions, referring here. So what do we do here? We solve the inequality. We graph the inequality, and then we described the solutions. Now I'm going to erase this because now I want to show you, sometimes they may ask you to describe the set of solutions in a sentence. So if we do that, we say all values of g that are what? Greater than or equal to (11). So if you're asked to describe the answer in a sentence, this is what it means. This is a math sentence. This is a picture or a model. Excuse me, this is a word sentence. This is a word sentence. This is a picture or a model, and this is your math sentence, and they all mean the same thing. All values of g greater than or equal to 11, right? All values of g greater than or equal to 11, and all values of g greater than or equal to 11. 3 phases of mathematical understanding. Okay, let's do one more. Let's solve one more problem where we have to solve the inequality and graph it, and then write a sentence to describe the solution. Let's go with, let's say you have -2, okay, and I'm going to say less than p plus 1. -2 less than p plus 1. Sometimes they give it to you and they write it this way. I say just rewrite it where you put the variable on the left side. So write p plus 1, p plus 1. And what is it? All right, it says p plus 1 is greater than. So write it like that, greater than, because it says it's greater than negative 2. You got to know how to read it so you know how to write it. P plus 1 is greater than negative 2. P plus 1 is greater than negative 2. Now let's solve this inequality. What property of equality are we going to use? Addition or subtraction? Yeah, subtraction. So we need to get rid of the positive 1, so we subtract 1. Whatever you do to one side of the inequality, you do to the other. Subtract 1 here and draw the line. Now remember, I always say write that to help you remember you're adding down. So adding down, p plus 0 is p. 1 plus negative 1 is 0, so you cross that out. Bring down greater than symbol. Negative 2 plus negative 1. Remember, you're adding down. Negative 2 plus negative 1 is negative 3. You lose $2 and then you lose another $1. You've lost a total of $3. Or in reference to the money in your pocket, you spend $2 and you spend another $1. You've spent a total of, your pocket is now negative $3, okay? That's another way to think about it. So we have solved the inequality. Now let's graph the inequality. And then we identify 0. All values of p that are greater than negative 3. So let's say negative 3 is right here. What kind of circle are we going to use? Open or closed? Look over here at your key. You're going to use an open circle. And it says all values of p greater than negative 3. So that means it's going to have to go to the right because these values are greater than negative 3. So we've graphed the inequality. Now let's write the sentence that describes the inequality. All values of p, we're going to say all values of p, all values of p that are what? Greater than negative 3. Hence, we have 3 phases of mathematical understanding. We have a math sentence, a picture or model, and a word sentence. They all mean the same thing. So thank you for watching. If you found this video helpful, remember to like, comment, and subscribe. And don't forget to check out my Patreon page on my video description below. On my Patreon page, you can get access to exclusive math lessons, study tips, live Q&A, and more. See you next time.